Hello everyone, my name is Connor Smiley, and in this video I'll be showing off my line following steering behavior Supervan Racetrack Extravaganza. Sorry, that title was a little bit overzealous, but hopefully you appreciate the enthusiasm. Anyways, what's going on right here is these four vans are using line following to project themselves onto the nearest line segment and then seek towards a prediction. So I'll show this off with some visuals to help explain in greater detail what exactly is going on. So I'll just run this for a single van. We can see right here we're using index 1 despite looping through all four vans, and we'll take a closer look. So we can see right here in white is the current projection, and this black marker bugs out momentarily, but it's the future prediction about half a second in advance of where this van is going to be. So the van is always seeking towards this little black marker right here, and it advances whenever the checkpoint is incremented when we pass through these capsule colliders. So let's peel back the curtain and take a look at the math for how this is being done. So once again, I'm in my engine that leverages the DirectX toolkit as a renderer. These are the only data members we care about. These are the debug visuals, so we're storing our racers as entities, so they have positions, colliders, and physics. Same with the checkpoints. And we've got some functions. Oh yeah, and our racetrack is also just a collection of four lines which have a start and an end position. So that way they know their direction. So we can ensure racers are always traveling clockwise around the track. And we've got some functions to create a racer and make them follow the track. So let's take a look at those two functions. Create a racer isn't really the point of this video. It just generates an entity, which is simply an identifier. It spawns them halfway between their respective line segment, and it gives them a random velocity as well as a capsule collider, and that's it for the racer. The interesting part is the follow track. So given an entity, and I recently added these two current and future outputs for the debug visual, but those aren't super important because they're just written to right at the end. What happens is, given our entity's position, we start out by finding the nearest projection along the racetrack. So we project the position onto all lines of the racetrack and then find the closest one based off a simple distance calculation. So that line segment is assumed to be the one we want to follow. So given our so we start off by getting our nearest projection, and from there we want to determine the end of the line segment, which is going to be used to find the direction in which we want to seek towards. But in order to ensure we're seeking towards the correct target, we first must test if we're colliding with the checkpoint. So if we are colliding with the checkpoint, we want to advance our target by one and bound it. Otherwise, we keep seeking along the current line segment. So we do that, we get our desired direction as a unit vector, and then here's where our prediction comes in. So we predict our distance based on a constant time of half a second, and once we have our physics information, what we do is we project along our current line segment based on our position plus half a second in the future. So we take our speed, which is the magnitude of our velocity, and we multiply it by the direction in which we want to move. And we also factor in our current acceleration just to add a bit of variance into our movement. So our acceleration is almost certainly not in which the direction we want to travel, but that's good because we don't want predictable linear movement. So yeah, we just use semi-implicit Euler integration from courtesy of our physics system. And once we have that, we can apply the resultant change as an acceleration by calculating steering force, by taking our prediction, our current position, and our current velocity, and clamping the maximum force we're able to generate to 750 pixels per second squared. So yeah, if I recompile this with both the current and future predictions of all the racers, it looks a little bit hard to understand, but that's what's going on. They're just seeking towards all of their black dots and then incrementing line segments and thus predictive targets when they hit the capsules. So if we take this off, we can once again see the Van Racetrack Extravaganza in all its glory, and we can create a bit of a traffic jam if we feel like being a jerk and want to test out our physics system. So yeah, thank you very much for listening. Take care.